Hello everyone, my name is Henry Yuqing. Currently, I'm a third-year mechanical engineer technology major undergrad student, and my advisor is Dr. Ke Du. The topic of my research for this summer is synthesizing zinc oxide nanostructure on 3D printed resin surface with low temperature. For this research, zinc oxide nanostructure synthesized on 3D printed resin parts will be used to increase the surface area inside of a microfluid virus detection device. This picture here illustrated how zinc oxide nanostructure were used on PDMS applications. When synthesized, first they synthesized zinc oxide on PDMS surface and then used it as a mold to create a microfluid device with increased surface area. Growing it on 3D printed resin parts has a similar idea as the PDMS application. So for the synthesizing method, I'll be using hydrothermal deposit method, and the setup is very convenient. Similar to this picture on the right, I'll be using a hot plate with a beaker on top of it. The zinc oxide growth media recipe was taken from a published paper, and the temperature was changed from 140 Celsius to under 100 degrees Celsius. Temperature was changed because the material property of the 3D printed resin. If it under higher temperature, it could deform or even melt. Here are some of the pictures of the specimens from my experiments. I have tried with different temperature, stirring intervals, solution concentrations, and pretreating methods. So far, I found that around 70 degrees Celsius, 50% concentrations and pretreated with ultrasonic bath works the best. As you can see on the very last two pictures, zinc oxide nanostructure were very evenly spread on the top of the 3D printed parts. Of course, just looking at it by eyes is not enough, so some SEM images were taken to help us better inspect the samples. And here are some zoomed in images. One thing we noticed was as the temperature increased, each rod of the zinc oxide nanostructure were getting more defined. As you can see on the top two, their temperature were both around 70 degrees Celsius, and it looks more like a nanoflower structure. And for the bottom two, the temperature goes around 80 degrees Celsius, and they look more like a rock structure. Later on, PDMS and glass samples were introduced to research. The same synthesized method as the 3D printed resin part was used for these two new materials as well. One big problems we found with these was there were many air bubbles forming on top of the samples and on the side of the sample, especially for the PDMS. So far, we found that using ultrasonic baths to clean it first and then treat it with oxygen plasma gun could greatly reduce the air bubbles. However, the distribution of the zinc oxide was still not very even. And here are some SEM images of the PDMS and glass samples. The PDMS samples are on the left, glass samples are on the right. Moving forward, I'll be experimenting with 3D printed resin parts with more complex structures, see how it performs, and be doing more experiments to find out the best condition for the PDMS and the glass, just not only to reduce the bubbles, but and also make it evenly spread. And I'll be testing how strong zinc oxide nanostructures were attached on different materials. And a hardness test could be one of them. And I'll be taking more SEM images to see how different concentration affects the zinc oxide nanostructures. It'll help us better understand it in the future. Thank you for listening. If you have any questions, feel free to leave a comment below. Thank you.